Hello everybody and welcome to this series on algebra. Before we get started, let us ask ourselves, what did the mathematician and philosopher share in common? Both could not solve for y. In algebra, we're often asked to find quantities that are unknown. In the last video, we said that unknown quantities were represented by literal numbers. And we spoke of some common literal numbers such as x, y, and z. And we said that literal numbers could have values that vary depending on how they were defined, so we called these values variables. So literal numbers could also be called variables. And we said that there were also quantities whose values did not change, such as 1, 2, 4/3, and so on. And these values were constant, so we called these values constants. So we have variables and constants. We also spoke a little bit about the word algebra, the origins of the word algebra, and how it comes from the Arabic word algebra, right? It comes from algebra, which means to restore. So to restore, to find an unknown. So in this video, what we're going to talk about is, what does this actually mean? When is an unknown actually known? Which, when you're solving for a variable, is another way of asking, when do I know when I'm finished? So basically, an unknown is known in algebra when the variable you're searching for has been solved. Because this is when you've made the statement, the unknown is something. So let us say that our unknown was the variable x. So this variable would be known when we made the statement x equals, which is another way of saying is, 4, right? Another example of a solved variable could be y is 3. If we look at solved variables analytically, we see that all solved variables have the same things in common. Each one is isolated. That means it's just next to an equal sign, it's by itself. It has a coefficient of 1, it's to the first power, and it has a denominator of 1. And its value is on the other side. But most variables are not solved. Sometimes you have a variable and it has a constant term next to it. Like for example, this one, 3 added to an unknown is 4. Or sometimes you have a variable and its coefficient is not 1. Like this one, 2 of an unknown is 6. Other times you have a variable whose denominator is not 1. Like this one, an unknown divided amongst 3 is 9. Other times you have a variable whose exponent is not 1, like this one. An unknown raised to the second power is 16. So next time, we're going to learn about the first algebraic technique for solving these types of problems when we learn about term movement. See you soon!